This tutorial will run you through the takeoff function, allowing you to calculate the volumes of materials and quantities of your site. Before this tutorial begins, we've imported vector PDF files and other data into Triple Business Center's Heavy Construction Edition. We then move the line work to the appropriate layers, where we rename them. Next, we elevated the original ground and finished surface line work. Next, we'll move on to adding materials to the MSI Manager. Here, we will create and manage libraries of materials and site improvements for takeoff operations and calculations. Right-click on Earthen and select New Earthen Material. Here we create a topsoil, so click Material Nature and select Topsoil. Furthermore, change the shading color to your liking. You can also input the material's shrinkage, bulkage, and unit costs. Repeat this step for sandy swell and rock materials. Remember to change the material nature according to the type of earthwork. Create a new material category named Pavement. In this category, create Concrete Heavy Duty and Concrete Medium Duty. Ensure that volume is selected in the Survey Basis option. You may also change the shading color to your liking. Next, you can create a new site improvement category named Pavements. Add into this category your pavement designs of Concrete Heavy Duty, which is area-based. In the quantification basis function, you can select for it to be measured planimetrically or by surface area slope distance. For this example, select surface area. There is also an option to add an installation cost, but you can leave everything else default. At the bottom in Site Improvement Materials layers, in the Materials column, select Pavement Heavy Duty. In the Thickness column, input 200 mils. Repeat this step for the Pavement Concrete Medium Duty with 150 mils thickness. Next, we prepare for takeoff layer calculations. In the Categorise function within the Takeoff tab, assign your layers to different categories including Original, Design, Utility, and Unused. Use the Original tab for layers and objects that contribute to the formation of the original ground. Use Design for layers and objects that should contribute to the formation of the finished surface. And use Utilities for layers with objects that models utilities, such as piping and electrical lines. Now we are going to identify the site regions. Assign the Concrete Heavy Duty boundary, Concrete Medium Duty boundary, and the Finished Surface Contours, FS Contours, to the Design tab. As made previously in the MSI Manager tab, we can assign materials to these layers with the materials we made earlier through the function called Associate with Site Improvement. Here we define FS contours as containing potential boundary lines. Following this, we assign the OG contours layer to the Original tab. And select Contains Potential Boundary Lines. Close and go to the Takeoff ribbon and build your surface. Ensure that you have 3 surfaces: Original Ground, Finished Design, and FD subgrades adjusted. Moving on to the Define Strata function, we will define the earthen material strata that exists on your job site to make the depths and thicknesses for each stratum definable when you create your boring logs. For the original ground, we select topsoil. Next, add the surfaces sandy swell and rock. we associate them to an earthen material we've created earlier in the MSI Manager. We select depth within the model type column for both sandy soil and rock. Next, we will create boring logs to represent locations of where you have core sample data describe the in-situ strata of earthen materials on the job site. Given the boring logs of the site, we will add a name, define a layout for our borehole logs, and input coordinates of the logs and its elevations. In boring log stratum settings, input your thicknesses of your stratum material. Next, we define topsoil. As we have already defined strata and boreholes, we will strip to the uppermost stratum or your specific thickness. Ensure the topsoil material is selected in the native topsoil material drop-down menu. We know the depth of the strip to the sandy soil, so now we need to define the horizontal stripping boundary. Click in the closed line box, in Options, in Select by Layer, and then your boundary layer. Then push the Add Update button. If you then rebuild the surface, it creates one more surface called OG with topsoil stripped. In your plan view, use the surface slicer view to check any surface by slicing vertically to create a quick profile. Navigate your way down to the surfaces function and turn on your desired surface to view in your surface window slicer. You can limit the surface to display only the area of interest by using the surface boundaries function in the surface ribbon to add a boundary. Finally, we will move to generating a takeoff report. The takeoff report automatically reports on the differences between specialized takeoff generated surfaces, each of which are formed as part of the takeoff workflow. Here, you can select the following sections you wish to include in your report. Other options, such as report coverage, allow you to consider specific areas of interest, and can also account for shrinkage, bulkage, and borrow materials. Reports can be generated in a concise report, explanatory report, or an Excel file.